Maybe it'll show me. That's good. Okay. So today we're going to go over adding and subtracting fractions. And I mean, I want to take you back to the old school first. And let's see, how do you add 3/8 and 7/8? Well, if I told you to add three dogs and 7 cats, you can't do it because it's just 3 dogs and 7 cats. But when the thing that you're adding is the same, we can combine them, almost like combining like terms. 3/8 and 7/8. That gives us 10/8. Everybody agrees with that. You could think of it exactly, and I mean exactly like combining like terms. 3/8 and 7/8. That's going to equal 10 of them. Okay? 10/8. Now, after we add, we always have to check and make sure, can we reduce? And we reduce by factoring and finding a common factor that we can cancel out. Your answer here is going to be 5/4. Now, that's not too tough. It's just numbers. It's what we did in elementary school. But if you look at the process here, you can see much more deeply what you were actually doing. And you can now apply it to algebra. Okay? Let's try subtracting right off the bat. Let's say I have 5x plus 1 over x squared minus 9 minus 4x minus 2 over x squared minus 9. The first thing you have to do is look for common denominators, and we have it. So put that on the bottom, and now we're going to combine the tops. The first term, or sorry, the first fraction, 5x plus 1, the second fraction has a minus in front of it. So you have to do the following. Now I'm going to put parentheses just so it looks better. Minus 4x minus 2. Okay? Now we have to simplify the top. Distribute the minus sign, distribute the nothing. When I distribute the minus, I get negative 4x. Minus negative 2 means plus 2. Be careful. Okay. 5x take away 4x. Combining like terms, we get x. 1 plus 2 gives us 3. Now the bottom, can we factor it? The answer is yes. X minus 3, x plus 3. I can see that my x plus 3's cancel out. This is like a whole big chunk up there. When you have nothing left on top, you have to put a 1. My simplified answer is 1 over x minus 3. Now I have to put my excluded values. In my factored version of the bottom, the denominator, I can see my excluded values. X cannot equal 3 because that would make a 0. I can go all the way back here and see 3 would make the denominator 0. Also, negative 3 would make the denominator 0. This is my complete solution, including the excluded values. Give me a thumbs up, thumbs down, thumbs sideways. Let me know if you understand that. It's looking good. Okay. So normally I would give you a problem to try right now, but we're going to go on with this and we'll try them after the video. Okay. So what happens if you have different denominators? Well, let me put an example up here and let's take a look. If I have x plus 2 over 2x minus 3, and I'm going to subtract 4 over x plus 3. Now, this is just like kids, okay? First, you have to factor the denominators, and then you have to say, what does one kid have that the other one doesn't? Now, these are already factored. This is nice. So I'm going to use a different pen to show how we get common denominators. You see this x plus 3 here? It needs this. It doesn't. This kid here has a 2x minus 3, and x plus 3 is crying because he wants a 2x minus 3 as well. So I'm going to multiply top and bottom by what it doesn't have. That's my new denominator here. Over here, likewise, I'm going to multiply top and bottom by x plus 3 because that's what it doesn't have. X plus 3, x plus 3. And you need to put these in parentheses. Okay, well, we have a common denominator now, and I'm going to leave it in factored form. The numerator, that's a different story. We're going to multiply it out. First, let me do this one. And you can use the box or FOIL or whatever method you like for multiplying polynomials. You get x squared plus 5x plus 6. And we have a minus 4. Look at this. I like to distribute the minus 4 directly. It gives me minus 8x and then plus 12. Now to simplify the top, I have an x squared. I have 5x minus 8x. And I have a 6 plus 12. The bottom is still factored as x plus 3, 2x minus 3. I have to see if I can factor the top, so I'm going to do a diamond problem. 18 goes on top, negative 3 goes in the bottom. Can someone tell me what numbers go on the sides?
Six and 3.
It looks like 6 and 3, huh? Let's see. What is 6 plus 3? That's 9, right? That doesn't equal negative 3. Should we change something here, maybe? Try again.
6 and negative 3.
Let's try it. Is 6 times negative 3 equal to positive 18?
No.
Okay, so this is wild, but that's not factorable. This is our answer. All we need to do now is put our excluded values. We look at the two factors in the denominator and solve them for 0 to find our excluded values. If x plus 3 equals 0, x equals negative 3 is an excluded value. If 2x minus 3 equals 0, we solve it, add 3 to both sides. 2x equals 3 divided by 2, and 3 halves is our other excluded value. Okay, there it is when we subtract and simplify. There are my excluded values. Does anyone have a question?
Yeah, so the excluded values is like the second part of the answer.
The excluded values is the second part of the answer, and we go over it quite a bit in the video from last night. So be sure after school to play the video and look at simplifying rational expressions. Also, I told you to read the sections, and actually that's pretty important because maybe you don't want to hear my voice on the videos. You can actually go to the books and read about excluded values and everything about simplifying rational expressions there. This time I'm going to give you an example to try. You guys try it. I'll give you 30 seconds to go on it, and then we'll start doing it. Okay. 3 over x plus 1 plus 5 over x minus 1. You can keep working on it and check it with my answer at the end. First, I look at the x minus 1 and say, what does this denominator not have that this one does? That one has a factor of x plus 1. I'll put parentheses here. What does this one have, the left side, that the right side, or what doesn't it have the right side has? And that's going to be an x minus 1. I now have common denominators, x minus 1, x plus 1. I will leave it factored so that I can possibly cancel out factors later. Now, distribute your 3. Get 3x minus 3. Distribute your positive 5. You get 5x plus 5. Simplifying the top, I get 8x plus 2. I have x minus 1, x plus 1. I can factor a 2 out of the top, but I can see that it'll cancel with nothing here. So I'm going to leave it alone. You can justify that on your own. My excluded values are 1 and negative 1. Any questions up to this point? Okay, I'm going to remove the paper here. You can check it on the video later today. And now let's do what's going to be our most complicated example for the day. I want to add 7 over 5x squared plus 15x and 9 over x squared plus 6x plus 9. Those are not common denominators. In order to find a common denominator, I have to factor each denominator. Right here, I can factor out a 5x. And I'll have 5x times x plus 3. Over here, we have a trinomial where you can do the x, you can do the diamond problem, and we're going to get x plus 3, x plus 3. Kids are crying because the other kid has something they don't have. Let's start over here. What does this guy have that this one doesn't? The answer is a 5x. If I put a 5x over here, then there's nothing here that this one doesn't have. Now let's go to this side. This guy only has 1x plus 3, and he's crying because this one has 2 of them. Let's multiply top and bottom by x plus 3. I can see the two denominators now look identical. That is our common denominator. And I'll write it as 5x, x plus 3 squared. Now let's simplify the top. Distribute your 7. Distribute your positive 9. Combine like terms. 52x plus 21. 5x, x plus 3 squared. And nothing factors from the top. Therefore, we're done. When looking at our excluded values, you have to look at each factor of x. This first one says that x cannot be 0, because if I put 0 here, we'll get a fraction of 0 on the bottom. This one says x cannot be negative 3. If I put a negative 3 in the parentheses, the entire product will be 0. This is your answer. I invite you to go back and rewatch that and maybe hit pause before I do the problem again to see if you can do it on your own. Okay? Do you have any questions on this one? Any questions you give me will probably help other students. Give me a thumbs up, thumbs down, whether or not you understood it. Thumb sideways if you think you need to study it more. Looking good. I'm going to stop the recording now.